Alright, so the last two examples for the hidden quadratics. The next one's a little interesting because you could probably just expand it out, but if we keep using the trick, you'll notice that what's in the parentheses here, if I let that equal to a, and then I was to square it, right, I get what's in parentheses right there squared. So classic hidden quadratic. So if I make those substitution, this part's a squared, that part's a, and we're right back to what's been going on. I now have a quadratic to solve in terms of a. So as promised, this should factor. So we get a, I think this will be -2, and a -10 should get the trick done there, right? A squared, negative times a negative is a positive, -2, yep, that's going to be it. So the zero factor property now says that a -2 is 0 or a -10 is 0, and so we basically get a is 2 or a is 10. Alright, now that's what our solutions are in terms of the a world. So we got to walk it back. So a is equal to x squared minus 2, and right now it's also equal to 2. So if I put these two together, that means that x squared minus 2 is 2. Or if I put these two together, right, that means that x squared minus 2 is equal to 10. So I now can walk my story back and solve for a. So over here, if I add 2 to both sides, I get x squared equals 4. Take the square root, introduce my plus minus, and we get two answers, right? X equals plus or minus 2. Over here, if I add 2, we get x squared equals 12. Take a square root, add my plus and minus, right? We get x equals plus or minus the square root of 12. What we saw earlier in chapter 10 is this is the square root of 4 times 3. So if we simplify that, we get plus or minus 2 square roots of 3. So we basically get 4 answers here. Excuse me, lost my voice there. And again, since this is technically going to be a polynomial, right? The domain's everything. There's no restrictions. My math, as long as I trust it, I'm pretty sure that those two answers, even though they're, especially this one's a little tough, they're going to check out, all right? Because, again, we have x squared here, and that's a nice parabola that's has a very strong domain. So there's basically that hidden ball trick with that guy, all right? Last but not least, using it one more time for this crazy situation, all right? Again, we're going to let a equal that middle part, right? So a equals x to the 1/3 power. If I square a, right, and then multiply my exponents here, I get that a squared is x to the 2/3 power, which is that first part. So making my replacements, this is a squared plus a minus 6 equals 0. There's my quadratic in terms of a. I'll factor this. I believe the factorization will be that guy, right? 3a, yep. And so my zero factor property says a plus 3 is 0, or a minus 2 is 0. We get a equals -3, or a equals 2. All right, so again, we want to solve for x, not for a. All right, so a just kind of helped us get there. So we're going to walk the story back. So if a is x to the 1/3, and a is -3, right? If we put these two together, we get x to the 1/3 is -3, or x to the 1/3 is 2. Right? So now recall, what did it mean to be x to the 1/3 power back in chapter 10? Well, that was a cube root of x, right? So that's essentially what we're saying here. And so how do I get rid of a cube root? We cube. And if I do that to one side, I do it to the other. So I'll do it to all this stuff here. And here the cube of a cube root will clear that out. -3 cubed is -27. Over here, that'll clear the cube root out. 2 to the 3rd is 8. All right, and then again, kind of recalling about x to the x to the 1/3 being the cube root of x. What we saw, right, is the cube root of x handles everything. It's a very strong function again. Its domain is everything. So I'm going to trust my math yet again and I feel pretty confident, right, that those two answers will be the solution. If you want, how about I just check one, right? So this guy right there is the cube root of negative 27 squared plus the cube root of negative 27 minus 6 equals 0. I can move that out and say this is the cube root of negative 27 squared. We already know that that's negative 3, right? The cube root of negative 27 is negative 3 squared, right? This is going to give us a negative 9, and 9 plus 9, negative 9 does in fact equal 0, so that checks out. Right, and you'll find that the 8 also checks out relatively nicely. So there's a really quick check just to make sure that you're not doing that. But when I start off with something, as you've seen a few times in this section, and when I start something off with a very strong domain, as long as my math is right, I'm pretty confident that my answers that I get in the end are going to be right. All right, so you don't have to worry about extraneous in there. Alrighty, so there you go. There's our hidden quadratic trick for situations that don't start off quadratic. But after looking at them, right, I think this is the original thing that we had, right? So none of these equations started off quadratic, but after making a substitution, we found out that they could be rewritten as quadratics. We solve it in that new variable, and then we walk our story back to the original variable to get our solutions in terms of x. All right, so that wraps up chapter 11.5. All right, I'll see you guys later, and you guys go practice doing some homework. Make sure you're Talk to you later.